Hello, everybody. Hope everyone's safe. Greetings to Dr. Dini. Let me introduce myself and my group mates. I'm Sarah Sabri Hassan, and I collaborated with Zhongli Hao, Ren Fifian, and Fong Yon in this assignment. We would be presenting a prediction of whether patients have heart disease according to the relevant characteristics. Let's move to the summary. Death related to heart disease have been an important concern in the modern period. Due to heart attack, roughly one person dies per minute, millions per year. During a heart attack, the heart is unable to transfer the requisite blood flow into the other parts of the body. And in some way, the diagnosis of such condition from the traditional medical practice have been considered as not correct. In our research analytic approach for the prediction of heart attacks, we developed a machine learning-based system using heart disease databases. Because of the exponential increase of information technology, data is generated and must be processed every day by using different variations of algorithms. The data obtained is transformed into information by data processing. So now we can come to the next point, which is introduction. The prevalence of cardiovascular disease have been gradually increasing across the globe for the last few years. While these diseases have been regarded as the most critical causes of death, they have been described as the most manageable and preventable diseases. Almost millions of individuals are affected as the results of changes in their lifestyles. The prevalence of heart diseases also have many factors, including smoking, high cholesterol, lack of physical exercises, and lack of food. Heart disease is one of the prevalent illnesses that more patients are affected by. The heart is considered as the primary source for the cardiovascular system. Both parts of the body are flooded with blood by the heart. Blood carries oxygen that is needed for all the body cells. Cardiovascular disease occurs because there is no proper function of the blood vessels and the heart. Heart attacks typically arise as the blood clots that block the flow of the blood to and from the heart. Hospitals are now compiling lists of patients who track their management and clinical records for the future use. The data for the prediction of heart disease is more important here. The main goal is the discovery of knowledge to discover the elusive patterns that has been previously detected. This system provides a vast volume of information. They are used to help make good health decisions. These patterns are identified. They use data mining for clinical decision making, which is an ancient approach. Current information that can be supplemented by artificial intelligence is needed. The proposed approach explicitly classifies the patient data by taking the various parameters into account and produce the conclusion correctly. It also indicates when the patient have the condition. It employs 4 algorithms to improve the accuracy score. Compared to the previous work, logistic regression yields the best accuracy for the 4 algorithms. If a person has a heart attack or not, it's impossible to determine. It also describes how in the future machine learning can contribute to heart diseases. What's logistic regression? Logistic regression is a mathematical model that, although many more elaborate extensions exist, uses a logistic function to model a binary dependent variable in its simple form. Logistic regression calculates the parameters of the logistic model in the regression analysis. Let's define the problem. Heart diseases may be successfully treated with a combination of changes in diets, medicine, and in some cases surgery. With proper treatments, the symptoms of heart failure can be minimized and the role of heaven can be enhanced. The key purpose of our work will be to accurately predict with a few variables and characteristics that existence of heart disease. Considered attributes form the primary basis and have detailed data for experiments. Many more inputs characteristics can be taken, but our aim is to estimate the risk of heart disease with the little characteristics and quicker events. Decisions are often made based on physicians' intuitions and experience rather than on the information rich in fact hidden in databases and datasets. This behavior leads to harmful biases, errors, and large medical costs that influence the quality of health care offered. Next point, objective of the project. The project aimed to predict which function is the primary risk factor for the heart disease, so we can tell here. The proposed solution would be used to predict how heart disease is triggered, and then persons at the risk of heart disease will be dealt with in advance by evaluating the possibilities of each factor leading to heart disease to reduce the risk of heart failure mortality. The computer will discover and extract latent disease-related data from a historical database of cardiac data that aims to exploit medical dataset for data mining. Techniques to help forecast heart disease prediction methods provides a fresh response to pattern in secret data. Using authentic data to overcome constraints inherent in a small medical research dataset can be a solution to safeguard patient privacy and allow the implementation of machine learning algorithms. The large datasets allow access to a large range of observation for the machine learning algorithms, from the opportunity sites training and testing portions to gain from practice, and then to be evaluated on another large selection of observation that have not previously been applied to the model. As computers modeling and simulation techniques, such as data mining, have the potential to create knowledge-rich ecosystem that help greatly increase the efficiency of clinical choices. This guidance is encouraging. The main topic is prediction using machine learning algorithms. Thank you.
So I will talk about the relevance of the project to the problem. So our problem is we want to predict the patient's currently physical condition, which is the features of the dataset that will affect the patients to get heart disease. So in our project, we will use the logistic regression. It also known as classification algorithm. Inside the classification algorithm, we will use binary classification. So what is binary classification? Binary classification is used to classify the value or the result into two groups. For example, 1 and 0 or true and false. So in our situation, we want to determine whether the patient get the heart disease or not. So by the way, we will use logistic regression in our project. So it should be classified from the details in which we have to separate the data depending on the characteristic of the heart of the patient so that we could know the illness of the patient currently. So in our project, we have set the independent variable and dependent variables. So our independent variable are age, sex, chest pain type, resting blood pressure, serum cholesterol, fast breathing, pressure resting, electrocardiographic results, maximum heart rate achieved, exercise-induced angina, ST depression induced by exercise related to rest, the slope of the peak exercise, ST segment, number of major vessels, color by fluoroscopy, and thalassemia. So next, our dependent variable will be our target, which we want to determine the patient who will get the heart disease or not. So our group will use logistic regression for the dependent variable on each of the independent variable.
Now, I'm going to talk about the methodology of the data analysis available in Python. In the beginning, we select the heart disease dataset, UCI, from Kaggle and import Python. Here we can see the records and the 14 attributes in the dataset. And all the data type are numerical. The second main step is preprocessing. Data preprocessing is the process of cleaning the transformation or coding data into a state that can be easily part the characteristics of the data can be easily interpreted by preprocessing. Now, let's clean up the data. The first step in the data cleaning is to check missing values in the dataset. Missing values will reduce the statistical ability of the model because it reduces the number of the samples, which will lead to waste of information and possible bias of the analysis. Through checking, we can clearly see there is no missing values in the dataset. Then we will do duplication detection. As we can see, there is a duplicated record in the dataset, but the dataset doesn't have a permit key, so we don't need to delete this. After that, we might do data discretization. In order to simplify the logistic regression model, make the model more stable, reduce the risk of overfitting, and take into account the type of data, we need to discretize the data with one-hot encoding. Usually, some features will have various non-numbers or special symbols when we get a new dataset. In fact, the data required for machine learning models is numerical because only numerical for all kinds of special eigenvalues, we need to encode them accordingly, which is also a process of quantization. But fortunately, all the value is numerical now, so we do not need to do level encoding. Moreover, we can see that the H6CP, the TRESS TPS, the CHO, the H6CP FPS, ResTag, the Exxon, slope, CA, THAL, and target have fixed values, which will lead to a problem. The model will automatically assume that there's a relationship between them, like 0 is less than 1, 1 is less than 2, 2 is less than 3, etc. But target is the predicted feature, so it does not need any change in this step. Therefore, we need to use one-hot encoding to deal with such unordered discrete values. Here, the edge is divided into 3 sections, which are used from 18 to 40, the middle edge from 41 to 60, and the older from more than 60. Then the HCP FPS, the ResTag, Exxon, and slope CA and THAL are encoded. So let's move to the outlier processing. The final step in the preprocessing is to deal with outliers. The appearance of outliers often affects the accuracy of data analysis. In general, the outlier is a group of values that are too large or too small and stand out. However, there is no clear criterion for judging which observations are outliers. It actually depends on many factors. Here we are only dealing with ordinal variable, which are trust BPS, CHO, we visualize these features using boxplot. Each black dot on the graph can be viewed as an outlier. So after determining the extent of outliers, we choose to use the quad difference to detect the number of outliers contained in each feature. Then we computed the position of the outliers as true, and put them in an array. Then we identified a method to remove them from the real-time dataset. Then we can see with our layers have been removed. Next step is data mining, which is a process that used to extract usable data from a larger set of any raw data. Uh, it is also known as knowledgeable discovery in data. Before we can properly construct the logistic regression model, we need to ensure that all data types are consistent. So we can see there are all the data type is float 64. Then we can use function describe to get some extra standard deviation, the minimum, quartile, and maximum of each feature. In addition, we can find relationship between targets and any features and other features with function scatter. The function applies a for loop to display all the relation diagram between label data and another feature. Before partitioning dataset, the features not associated with label data should be removed. So correlation analysis is necessary. We visualize the correlation features and rank their Pearson correlation coefficients. In the process of feature selection, we removed those features whose Pearson is lower than 0.3. The real-time dataset after feature selection will be divided into training set and test set in a ratio of actually 4.1. And in the modeling part, we choose and feed a logistic regression model to carry out machine learning. So I will pass to Rifan to present the prediction and evaluation part.
Okay, so the independent the independent variable and the dependent variable of the test set were predicted through the logistic regression model, and the results were put into array, represented by 0 and 1, and matched. The result obtained by was that the average accuracy of the model was 1.0. Later, the same dataset was put into the KNN model for prediction, and the average accuracy obtained was about 0.89. Compared with the KNN model, the model we used was more accurate. And next, from the confusion matrix and the classification report, we can see that the logistic regression model can accurately predict and classify different types of sample data. The precision rate, recall rate, and the F1 score of the two operations are all up to 1.0, which indicates that the model can carry out accurate experimental prediction. So accuracy rate is shown at 1.0. The Markov average, weighted average, and the Kappa coefficient are all at 1.0, which fully shows the high accuracy of the model. And then next, in terms of the relevant importance of data, patients with zero major blood vessels in fluorescence staining are more likely to cause heart disease than other patients, while patients with typical angina, severe hypoglycemia, and a flat slope of the PEC exercise ST segments are less likely to cause heart disease. The least influential factors are non-anginal pain, downsloping of the PEC exercise ST segment, and the maximal heart rate. In addition, heart disease is associated with ST depression induced by exercise, sex, and exercise-induced angina. And next, according to the ROC curve and the AUC value of 1.0 obtained from the experiment, the higher the authenticity of the model detection method we used, the more valuable it will be. So, okay, that's all for me.
So for the future enhancement part, in future we could split the dataset into 3 segments, which are 60% of the data for training, 20% of the data for testing, and another 20% for cross-validation instead of what we do currently, which are 70% for training and 30% for testing. So why do we need 20% for cross-validation for the dataset? So cross-validation can help us to reduce the overfitting and hyperparameter tuning. By using cross-validation, we could split the data into few folds and do trainings on the algorithm with different types of folds. This could help to prevent overfitting occur. So it could also help to figure out the best value of hyperparameter to increase the efficiency of the training model. So by the way, during doing the training and testing, we could try to use different algorithm, especially when the dataset is too large. If our dataset is large and with more features, logistic regression might be not suitable for it. So we might try to use decision tree on it. So decision tree could help us to be more understanding on our dataset, and we can do explanation on it easier. Besides, we are easier to visualize our dataset. So the algorithm that we choose is based on the size of dataset and its feature. Thank you.